Once again, very good morning to you, ladies and gentlemen. And if I may welcome you to the Royal Society and this conference on From Satellite to Soil. My name is Martin Sweeting, and this conference is part of the Breakthrough Science and Technologies Transforming Our Future series that the Society has been holding, aiming at addressing the major scientific and technical challenges for the next decade. Each conference that's been held in the series brings together leading experts from across various disciplines who will reflect the state-of-the-art knowledge in both industry and academic centres of excellence. Alongside the current and future direction of science and technology, the conferences also aim to address major political, social and economic impacts and issues, including the current state of the industry, the UK and international context, opportunities and barriers to commercialisation, and the skills base that is needed to deliver major scientific advances. Space, of course, now is embedded in our everyday lives as critical infrastructure supporting communications, navigation, and today, Earth observation. Last year, the Royal Society and the Government Office for Science commissioned a report on observations. Copies can be found on the website. As a briefing to the government, better to support policy making and looking at the whole range of sensors and platforms, and of course, space being a major source of data. The rapid advances in satellite technology, coupled with the terrestrial computing, the so-called big data, is just beginning now to offer new and uncharted opportunities for exploitation of this data source. However, it is also very clear that we're not yet utilising the capabilities of space for maximum benefit. In some areas, such as the GPS and shortly Galileo, Beidou, global navigation systems, we have seen increasingly seamless adoption into apps of all kinds, most of which were not predicted even a few years ago. However, the exploitation of Earth observation data to generate ubiquitous, actionable knowledge for users is still very much in its infancy. The use of space-derived Earth observation information to benefit land use and agriculture is one such area. But the space and agriculture, if I may summarise them as those communities, do not find many opportunities to interact directly to explore how best to exploit these new capabilities. So today's conference is therefore most timely, and I encourage participants not only to interact today robustly, but also to take away ideas and contacts to follow up and put into action, whether it be more fully to exploit existing capabilities or identifying new requirements for the next generation of future satellites. It's a pleasure, of course, to welcome you all here today. And also for me just to say a word of thanks before we start to my co-chairs, Stuart Martin, Prof. Melanie Wellham and Minette Batters, and of course the staff of the Royal Society who have helped bring this programme all together. The first two talks in this morning's sessions aim to give a broad overview of the area of environmental observation and its use in Agritech from the international and UK perspectives. And then this afternoon we will have, and that's why you're all clustered around tables, we will have some table discussions in which we can start to pick apart some of the specific opportunities and issues. So, without further ado, I'd like to introduce the first speaker this morning, Dr. Barbara Ryan. Barbara is the Secretariat Director of the Intergovernmental Group on Earth Observations, or abbreviated to GEO, located in Geneva, and coordinates the activities of 101 member states, the European Commission, and 95 participating organisations who are integrating Earth observations to make informed decisions across the 8 great societal areas of benefit. So, with no further ado, I would very much like to introduce and welcome Barbara to the stage.
Well, thank you very much, and it's a pleasure to be here. And I'd like to thank members of the Royal Society and the staff and all the conference organizers. Yeah, I would like to talk about leveraging Earth observations for a more food secure world. And you'll see from many of these slides, we're going to be talking at a fairly high spatial level. But I guess what I'd like to do is kind of set the stage that it can in fact be downscaled more locally. And while maybe some of the slides are not going to maybe address some of the needs that we've talked about over the last day or so with really particular precision agriculture, there is data available, but you're going to see that the primary focus on this are that information that governments have paid for, collected, and the systems that they are designing to do that. So I just want to say that when we in the group on Earth observations talk about Earth observations, it's any observations in, on, or around the Earth. So it could be in fact from satellites, much of the topic of this conversation, from atmospheric sensors, from terrestrial sensors, from marine sensors, and actually from those sensors inside the ground also, so whether it's groundwater measurements or geodetic measurements, so any observations in, on, or around the Earth. And I think what's maybe most relevant here is a quote that former MSNBC commentary person Dylan Ratigan said, "Uncertainty is the enemy of investment, and shared information is the antidote to uncertainty." And so the theme that's going to transcend or transect this entire presentation is really the importance of shared information. So let's look at monthly wheat prices, 1960 out to the decades of the 2010s. And you can see that in the first part of this graph, 60s to 70s, relatively stable pricing. These are global wheat prices, US dollars per metric ton, sources the World Bank. And yet, shortly after that, early 70s and 80s, we start seeing rather significant swings. And by the time we get out into this last decade, swings on the order of 3 times what it was back in the 60s and 70s. And so again, we can look at selected events, and certainly the impacts of climate change will be substantial, whether it's droughts in this particular area. But the thesis here is that if you do in fact want to create a more food secure world, wouldn't it be nice if we could get back to some rather more stable pricing strategies? So global wheat prices. So come into the 2010s, 2011s, 2012s, many of the major newspapers and magazines talked about the crisis of that particular time and the impact that these conditions were having globally. So a little bit before that, the Group on Earth Observations, our organization, had maybe we would call it a community of practice. A number of countries, number of participating organizations that would come together. You'll see them up at the top. And said, well, listen, if we wanted to bring, in this case, space-based information together, but some in situ measurements, to actually just start looking at vegetation health. The indicator here is NDVI, or normalized difference, vegetation index. So it's you can see that this is one particular day, a global shot, August 13, 2012, and the colors on this graph just show the difference on August 13th to the 10-year average of vegetation conditions before August 13th. So again, pretty healthy vegetation in southern Canada and some of the rice growing areas, drought conditions in the central United States, certainly drought conditions through Europe and Russian Federation. And then again, we can get out into Asia and start to see healthy vegetation. So the point here is if on one day, August 13th, you can get a snapshot like this of average conditions compared to the previous 10 years. How come we're not doing a better job of bringing this information in to our into the entire agricultural sector? This is a little bit of a close-up of those same areas. So difference between one day again, July 17th, 2010, July 17th, 2012, and you can see differences whether they're in the Ukraine or whether they're in Russia and Kazakhstan, and the impacts that it has. So 2010 grain production decreased by 30%, wheat prices rose over 80% in those 6 months, and similarly the drought affecting crop production in Russia, Ukraine, Kazakhstan in 2012. So when that community of practice in GEO got together, largely through some connections with France and the France agricultural minister, the G20 agricultural ministers started paying attention to this particular effort and said, listen, if we want to improve crop production projections, obviously you need weather forecasting with the use of modern tools, then let's look at the work that the Group on Earth Observations has done through its Global Agricultural Geo Monitoring Initiative. If you were at the dinner last night, this is in fact the program that Tim Benton talked about, but said that's the Earth observation side of the equation. What we would encourage you, GEO, to do is work with AMIS, the Agricultural Marketing Information System entity and FAO at Rome, that's more responsible for actually assigning the prices to those conditions. So about 2011, this GeoGlam effort started to get more political attention, largely because of the G20 agricultural ministers. So since September of 2013, the Group on Earth Observations and its GeoGlam initiative has been providing to AMIS's Market Monitor a crop forecasting perspective. So global coverage of the four commodities, so wheat, rice, corn or maize, and soy or soybean in these 51 countries. Operational again since 2013, more institutions now, more countries, a number of international organizations for those wheat crops, or for those four major crops. So a little bit busy slide, but I guess this is the kind of graphical information that is provided to AMIS. And so conditions, color-coded fairly simply, exceptional, all the way down to where maybe no data exists. What those crops are in that particular area, and then maybe what the individual drivers are, whether it's atmospheric or weather conditions, or an extreme event that actually influences those conditions. So you can, in fact, in these areas now drill in for global conditions by those four major crops, in this case rice. You can then drill into a particular country's perspective on that particular crop, and again start to see the very simple color coding for the monthly conditions there. So this would have been August 2014 crop conditions for rice in Thailand. I guess maybe the other thing to say is that in addition to this information, obviously not just rice, but wheat, maize, and soybean. And so when we as scientists and Earth observation people are working with these policy makers, NDVI isn't particularly relevant to them, so there do need to be some surrogates to kind of translate some of this information that could be picked up a little easier. So when we think about making the case for improved crop forecasts, this is an aggregation of wheat production forecasts from those main wheat export countries versus the international market price for a couple years. So 2010, 2011, and 2012. And so you've got production forecasts in pink and you've got price in blue. And so you can see the inverse relationship that largely exists between price and forecasts. But I think what's I think quite important is, and maybe for this conference, is that in this day and age, with the technological advances that we do have and the resources that exist, whether they're on space or in the ground, how come we can't do a better job of, at the beginning of the season, predicting where we will be at the end of the season and leveling out these curves? And so I think it's a pretty good graph that maybe speaks to that. So drilling down just a little bit, this is from some Landsat data, so 30-meter data in the it happens to be in the United States, Waterloo, Iowa. Guess what I would say is let's look at this rectangle here. And all you really need to do is look at the top two colors, corn and soybeans, from 2000 down to 2012. So if we look at that rectangle, we're largely planting soybeans, corn, soybeans, corn, soybeans. About 2005, look at the next sequence all the way out to 2012, largely corn. And so the United States put some ethanol regulations in place at the time. Farmers were encouraged to grow corn. And so the regular routine of alternating those crops was disrupted until 2012, when those regulations were removed, and all of a sudden you see soybeans starting to come back into the picture. So I think this slide speaks to a couple things. One, that at least this scale, you can observe these changes from space. You can see the effect of regulations on the ground that individual countries can make or have made. And the other thing, from a data perspective and from a group of Earth observations perspective, the importance of archives. And so saving this data is really quite relevant so that we can go back in time and actually look at how the Earth's landscape is changing. So we advocate very strongly on the value of open data, that data that is paid for by citizens of the world, taxpayers of the world. It is in fact a founding principle for the Group on Earth Observations. Recently released a report about the value of open data, and it kind of marches through maybe 5 major reasons why this is so important: environmental transparency, capacity building, education, informing the next generation of young scientists, and economic growth may be most relevant for this discussion. So while we are upstream of what's largely going on with those decisions, we want to make sure that these decisions and actions for the benefit of all humankind are informed by coordinated, comprehensive, and sustained Earth observations. And you can dissect each one of these adjectives in terms of global coordination and comprehensive, space-based to ground-based, and the importance of sustained observation so that we do in fact have the ability to go back and look at these archives. So as Sir Martin said, we are looking at 8 societal benefit areas. Food security and agriculture, sustainable agriculture is most relevant here. 103 members. Mongolia just joined last week. While we are not a UN organization, you must be a member state of the United Nations to join GEO. And so pretty good coverage, Northern Hemisphere for sure, but you will see we still have some rather substantial holes: South America, Africa, certainly the Gulf states. And quite honestly, at 103 members, that's still only about half the member states of the UN, which I think maybe is 194, 195 right now. And so there are many, many member states in the Pacific Islands that, when you think about the impacts of climate change, are going to be most susceptible to rising sea levels. But also participating organizations, I think, distinguishes us from other UN organizations. So what you will see here are our 95 participating organizations, UN agencies, UN conventions. I've just circled a few that would maybe be relevant here for this audience. Certainly European Association of Remote Sensing Companies, European Space Agency, Agency, FAO, WMO, working very closely with the forecast, and the World Bank just came in. So if you want to start leveraging maybe this convening power that we have, it's an ecosystem, it's a community, and you really need to bring all the people together that have some role or voice or mandate in the importance of coordinated, comprehensive, and sustained Earth observations. We do have an infrastructure, largely a light infrastructure based on all these providers that exist around the world. There's kind of a thin infrastructure in the middle that will serve up data that's collected here so that applications can be built, I think largely by small and medium-sized enterprises or the private sector, so that those applications can in fact find their way into users' hands. So broad open data from many of our government agencies, emerging involvement from the private sector while the private sector operates under different data policies. The conversations that we're having with these companies is, could you just make your catalogs available for where you have high resolution data so that anybody coming into the portal could at least discover where not only broadly and openly data from government sources exists, but where the private sector has collected higher resolution data, even though you might have to pay for it. And so you're sent to those private sector entities. I want to be clear. This is the nerve center of the entire infrastructure. It's called a discovery and access broker, and so the data does not come into our infrastructure. It's just discovering and accessing what exists. So we often talk about being a brokering institution like Uber, one of the largest rental car entities in the world, but they don't own one rental car. Airbnb, largest hotel enterprise, they don't own one hotel room. That's clearly the same with the Group on Earth Observations, one of the largest accesses to Earth observations, and yet we don't own any of that data. You and governments and institutions own that data. Yearly queries into that infrastructure, 2014 it was about 400,000, 2015 2.5 million, and this year to date it's about, this says 3.8, it's now at 4.2 million. So I think we're finally reaching a tipping point where people are coming into the infrastructure to access that global data. I want to just spend the last couple of minutes talking about the importance of broad open data policies. This is a story that I have personal experience with in the United States. It's the Landsat story. This starts at 2008 and comes out to about now, but the first Landsat satellite was launched in 1972, so it would be over here somewhere on this graph. The United States sold Landsat data for $500 a scene when the government operated the satellite, $4,000 or $5,000 a scene when the private sector operated Landsats 4 and 5 in the mid-'80s. And at the peak of data sales, 2001, 53 scenes a day were sold. Now, 53 scenes a day times $450 a scene times 350 days a year, it's a substantial amount of money. At my organization, the Geological Survey, we were taking in about $4.5 or $5 million a year for selling those 53 scenes a day. Who was buying the data? Number one, other government agencies. Number two, universities funded by the National Science Foundation. Number three, contractors funded by the Defense Department. So we were just recycling that $4.5 or $5 million of largely federal money, incurring transaction costs to sell 53 scenes a day. We were finally able, and there was, for any institution that's selling data, you're going to get as much internal resistance to change in data policy than external resistance. And it was a difficult time because the federal government was saying, why would you turn your back on $4.5 or $5 million of revenue that's coming in? And we said, well, it's not really revenue. It's just changing this government money from pocket to pocket. Just give the data away. Let's just give it away over the internet. We already had the capability to distribute it over the internet. So in 2007, 2008, the United States used the organization that I now lead, the Group on Earth Observations, to announce a change in data policy. And this is what's happened. 2 orders of magnitude, 53 scenes a day, 5,700 scenes a day to this day are being downloaded of Landsat data globally. This number is well above 25 million scenes now of the entire Landsat archive. Great, it's being used, it's being downloaded. Okay, so we could talk about how it's being used and what effect it's having. And so a few years later, 2011, Landsat Data Advisory Committee put an economic analysis together and showed that in the US alone, this policy change resulted in $1.7 billion of economic return to the United States, $400 million globally, for a grand total of $2.1 billion. Luckily, far exceeds the $4.5 or $5 million that the Geological Survey was collecting. We believe this experience in the United States heavily influenced the Sentinel policy here in Europe, an outstanding policy, and I believe that in a few years, once we have kind of the data here in Europe, you are going to be able to show, one, similar growths in the downloads of that imagery and similar economic benefits. Canada, same thing, different data source. This happens to be RadarSat. They didn't open it up globally to the whole world or to all users. They just opened it up to other federal agencies and showed a 1 order of magnitude increase, 5,000 scenes a year up to about 40,000 scenes a year. So again, for government agencies to continue to sell data, not just space-based data, stream gauge data, soil moisture data. Number one, you're mostly creating a barrier to other federal agencies to use that data, and you're certainly, most certainly, creating a barrier to true economic growth, largely out of the private sector, to come in and build value-added products and services. So experience, and I think this maybe is quite relevant to the technological advances for this workshop. Australia ingested the entire Landsat archive into their National Computer Center, and so they happen to call it a data cube. And so what you're seeing here is that the entire pass for all the passes of the Landsat satellite over the continent of Australia have been brought into their National Computer Center, drilled down through that archive, rectified, I guess, is a good word, pixel by pixel, not just scene by scene, pixel by pixel, because the entire continent of Australia is moving. So a location today is not a location 30 years ago. And so in this case, they worked with their national flood risk people and said, okay, show me every single pixel, 25 or 30 meter square area, that has always been wet in that entire period of time, that has always been dry, that's been sometimes wet and sometimes dry for flooding or drought or whatever, and then let's start putting kind of a histogram or some colors together to show a particular pixel through that entire time. And what we would argue in the Group on Earth Observations is that countries need to start managing, or at least looking at, their landscape changes in areas like this, and technologies absolutely exist. What has been done here in Australia is sensor neutral. They are, in fact, talking to ESA, the European Commission, about doing the same thing with the Sentinel data, and that's just space-based data. Why aren't we bringing in situ data into the data cube as well, so that you really could start looking at landscape change? So this was done for water detection, happened to be 15 years of data, the nominal pixel resolution, the number of scenes, the entire archive, 3 hours of compute time at their National Computer Center. The data alone, if you had to pay the $450 a scene for the Landsat data, would have been on the order of $130 million to do this analysis. countries didn't do it. Nobody did it because you couldn't afford the data. So the whole dialogue, the whole conversation now has changed away from getting access to the data to what are we going to do with the data now that we do have it. Just real late, last night after Tim's presentation, I decided to come in and add this graph. So I don't know if he's in the room, but for anyone that was at dinner last night, this is the data that he talked about. So just real quickly, these are advances in global and regional weather forecasting, 3-day, 5-day, 7-day, and then 10-day forecasts from 1980 out to 2013 or 2014. So days associated with their forecasts. This is from ECMWF. Sorry, the credit was down here and fell off. First thing, look at the 3-day, the 5-day, the 7-day, and the 10-day. From 80 out to here, significant improvements over time across all those individual time periods. But look at the top line of any graph or any color and the bottom line. Top line is the northern hemisphere, bottom line is the southern hemisphere. And so from 1980 out to 99, the southern hemisphere forecasts lagged significantly behind those in the northern hemisphere, largely because of the limited land masses and the lack of access to in situ observations. Look what happened in the early 2000s with the northern and southern hemisphere forecasts finally coming together, and that is the introduction of space-based or satellite data. So satellite data could then compensate, particularly in the southern hemisphere, for the lack of in situ measurements to in fact help these global and regional forecasts. And so what Tim said last night is, I think he said the 5-day forecast today is much better than the 3-day forecast of a long time ago, and that absolutely is the case. You can look at the 7-day forecast today, and it was better than the 3-day forecast of 20 years ago. So if through a number of global monitoring weather modeling centers, ECMWF here in Reading, can do this for the atmosphere, how come we can't transition this to oceanic and terrestrial observations, particularly for as large as the entire agricultural sector is globally? So again, some mention of the Global Sustainable Development Goals. We worked really hard with the UN Statistics Division to just get these words, including Earth observations and geospatial information, into the documents, because this entire effort will largely be done by your statistical agencies, census bureaus, who may or may not know about the Earth observation and geospatial data that exists. And so for, at least at a very high level, for each of those 17 goals, we've gone through and done kind of the data that would be Earth observation and geospatial information that would be most relevant to at least contributing to those goals. So in closing, countries have borders, Earth observations don't. And I think it's just really important that if we do in fact want to unleash the power of Earth observations, we need to advocate for broad open data policies. It's absolutely needed for global monitoring and transparency, so that not just the wealthiest of us have access to that information, but we can in fact influence food prices. We must leverage the investments that are being made largely in space, but I would argue all in situ observations as well. Citizens globally certainly deserve more. So whether it's this young farmer or any of you in the audience, we have the ability, whether we have the will, to create a more food secure world is yet to be seen. The UK does participate in the Group on Earth Observations. DEFRA is the lead agency. Our plenary is in St. Petersburg, Russia this coming November, and there's website. So thank you very much. Turn it back to you.
Stay here for a few questions.
Okay.
Thank you very much indeed, Barbara, for setting the scene. And we now have some time for questions. I would ask that you just state your affiliation and also try to keep the questions as succinct as practical. Gentleman in the front row.
Yes, my name is Stefano Bonfa. I'm from Oxford Sustainable Development Enterprise. This is a European interest economic group. We started just now thinking about data satellite, how they can help in developing what we call it, what Europe wants to implement in Europe is called the smart strategy specialization. The question is, okay, we have such amount of data, portal, etc. How do you, I mean, if you don't develop any strategical movement where you can exploit the data in order to create economy. So this means what is missing now is the application in a more strategical way that I think some organization or government should think about this type of general framework. Otherwise, you can go, so what do you think about this?
Yeah. Well, it may not surprise you, given my background, that I actually think there are certainly you can control some things from a broad perspective. And I think the influence on policies is very important in that regard. But in my opinion, when you are really talking about the true uptake of this information, we can't even predict how this is going to be used. And so we've got to, I keep saying we've got to unleash the power of these Earth observations so that you can, in fact, unleash the creativity that exists. Perfect example, just real quickly, again, in my experience in the Geological Survey, we produced stream gauge information for 100 years. Finally delivered it out over the web instead of in paper. It was largely designed for transboundary and water resource assessments in the United States. As soon as we started releasing that stream gauge data over the web, entire industries were built, small sectors were built using that data to recreationalists. Should I take canoeists on this stretch of the river or that stretch of the river? I've got to drive 40 miles across my ranch to work. If the stream bed is dry, I can cut the transport time, down to 5 or 6 minutes. If it's not, I got to drive 40 miles around. And so I just think for us, it's the integration of these different kinds of information that are so important. And it's not being done largely because as government agencies, we collect this data in silos. We don't even share it with other government agencies, and it's sector by sector. So we've got to start breaking down those silos in our governments, and that's where the policy directives need to be, I think, not so much on how's the information, how are we going to control the products that are generated.
Another question for Barbara? Last orders?
Great. Thank you
Thank
so
you very
much.
much indeed.